Is air pure substance? No, air is a mixture. And when we think about air, air is 78.09% nitrogen. This is dry air. So 78.09%, is that percent by mass or percent by mole? It's not clear, is it? You know, typically when we look at percentages, it's what, mass percent. But let's see, because we need to know that information. Is that air? I mean, and it turns out it's a, look at this, it's a volume percentage. But you know, volume percentage, we know in Avogadro's law. What does Avogadro's law say? The volume is directly proportional to the number of moles. And so a volume percentage is the same as a mole percentage. Is a mole percentage the same as a mass percentage? No. And so this could be either mole percent or volume percent. And so volume percent is easy. If I have 100 liters of air, how many liters of nitrogen do I have? I'm going to have 78 liters. How many liters of oxygen? Close to 21 liters of oxygen. All right, so we're going to do a little stoichiometry problem here. We're going to put some glucose and or some sugar into a container. This container has a lid that can move up and down. And then we're going to put some air in here. So let's try to burn 5.15 grams of glucose. You know, how much air do I need to burn that much glucose? Just guess. How much air do you think is adequate to burn? Normally, when we burn things in excess air because there's plenty of air here, right? But let's say the room were sealed, you know, and so there's a finite amount of air, you know. Then if there's a finite amount of air, then what we have to do is we have to worry about limiting reactant, right? If we want to burn all the glucose, we have to make sure that there is enough air in this container. But this container is kind of sealed, you know, I sealed it with a lid here. Lid. So how much air should I put in there to burn the glucose? What do you think is enough air? A liter? 2 liters? 3 liters? Just take a guess. How many liters of air will it take to burn? Let's say you eat 5.1, this is what I'm asking. If you eat 5.15 grams of sugar, how much air do you have to inhale to burn it all? You think, what's your lung capacity? Your lung capacity is about a liter? 2 liters? Actually, there's a problem with the lung capacity. But the problem is do we use all the oxygen? No, we don't. 4 to 6 liters. 4 to 6 liters. But you know, we don't absorb all the oxygen in every breath. We just absorb a tiny fraction of that. Right? And so, what do you think? Do you have about 5 grams of sugar? How many liters of air? If we could use all the oxygen in the air, how many liters of air do you think it would take to burn it? Liters be enough, you think?
No.
Probably more. 100 liters? Well, the thing is, if the air is expensive, let's say you're doing this on the space station, you don't want to waste it, do you? No, you don't want to waste the air. Or if you're on a submarine, you don't want to waste the air. And so we would like to know. So let's just take a guess. I'm going to guess 10 liters? 10 liters? Okay. We'll just go with 10.0 liters of air. Hopefully that's enough to burn it. But when you see a problem like this, when we're given the amounts, you know, because we're trying to burn glucose. Glucose is C6H12O6. It's a solid. Plus, it's going to take 6 oxygen gases, make CO2 and water. And so what we're going to do is we're going to do this. We're going to do a simple calculation. We're going to try to figure out how much CO2 is produced of this. Then we want to know what the limiting reactant is and the excess reactant. So LR, excess. And so how do you do this? This is a limiting reactant problem. How do we do a limiting reactant problem? How much exactly? How much?
How much glucose was used?
No. So you want to go back and take a look at how we did this. And I'm going to stop here. Why don't you start working on this? You work with other people on this and then see. You know, if you get stuck, let me know.